Hello everyone, thank you for checking out A1 Math, and today we're going to do part two of solving a system of equations by substitution. Okay, so I'm going to go over the steps for doing that. They're the same as it was in the first part. Um, Set each equation equal to y so that it is in slope-intercept form. Y equals mx plus b. Set the mx plus b parts equal to each other. You're going to solve for x. We're going to substitute x into either one of the two equations and find the value of y. And then we'll have our coordinate with x and y here. Now, in the previous video, all the problems were already set equal to um, y, so that it was in y equals mx plus b form. Today, I'm going to work some problems where you have to set it up so they'll be in slope-intercept form. So let's take a look. Now, in this example, we have two equations, and one is already in slope-intercept form, but one is not. It's in standard form. So what I'm going to do is go ahead and solve for y, and then go ahead and follow the steps from there. So I'm going to take the 4x plus 4y equal to negative 20, and go ahead and solve for y. So the first thing I'm going to do is subtract the 4x on both sides. And when I do that, be careful not to subtract the 4x from the 20. They're not like terms. So you can't put those two together. All right. Once I do that, my 4x's will cancel out on this side, leaving me with 4y is equal to negative 4x minus 20. Notice how I put the negative 4x in the front so it'll look more like y equals mx plus b. All right. Now my next step is to go ahead and isolate this y by dividing by 4 all the way across. Okay. Once I do that, I'll have y is equal to negative x minus 5. With my negative 4 divided by 4 being negative 1, and my negative 20 divided by 4 being negative 5. So now I have it in slope-intercept form. Now my step 2 is to take the mx plus b for both parts and put them together. So I'm going to take this negative 7x minus 5 and set it equal to the negative x minus 5. All right, so that part and these two are being set equal to each other. All right, now I'm going to go ahead and solve for x. I'm going to add x on both ends. Now I have like terms, so I can add these two together. So the negative x plus x here and negative 7x plus x, we're going to combine those, and that's going to give me negative 5 is equal to negative 6x. So since I added an x to the negative 7, it's going to make it negative 6x minus 5. Next thing I'm going to do is continue to isolate this x by adding 5 on both sides. And once I add 5 on both sides here, that's going to give me a 0 over here on the left and negative 6x over here on the right. Now, if I continue to go ahead and isolate this negative 6x, I'm going to go ahead and divide by negative 6 on both sides, and that'll leave me with x is equal to 0. Now, my final step is to take this x is equal to 0 and plug it back in to my equation. And again, I could plug it into either one of these. I could even plug it in here if I want to, and solve. But you pick an equation. Let's see which one I picked here. I decided to plug it into this one. This seemed like the easiest one to work with. Now, that may not always be the best option, being that this is the equation that you came up with, and you may have solved it incorrectly. But here I went ahead and plugged it back in here. I plugged in the 0 for x. Okay, that's going to leave me with just y is equal to negative 5. And since it was 0, it's really easy to solve. If I put 0 here, that's going to leave me with negative 5. If I put 0 here for the 4x, and then divide by 4. Negative 20 divided by 4 is negative 5. So you would get negative 5 in either one of these equations you plug it into. Now I have my x is equal to 0 and my y is equal to negative 5. And I have my coordinate, which is 0, negative 5. Always be careful to make sure you put the x first and the y second. Okay, let's take a look at another example. Okay, here we have the 4x minus 5y equal to negative 3, and the y is equal to negative 5x plus 8. One of them is already in slope-intercept form. That may not always be the case, but all you have to do is make sure you solve it for y first. So I'm going to go ahead and take this problem here, 4x minus 5y equal to negative 3, and solve for y. So I'm going to subtract the 4x on both sides. All right, that's going to get me negative 5y is equal to my negative 4x minus 3. And notice I didn't really even do any operations here. I just went ahead and subtracted the 4x on both sides. All right, next, I'm going to go ahead and divide by negative 5 all the way across. And then that's going to leave me with my y being positive here is equal to 4 over 5. Negative divided by negative is positive, so it's 4 over 5x plus, again, negative divided by negative is 3 over 5. Okay, now this is where it gets tricky. You've got these fractions here, and it can be kind of difficult as far as doing operations with fractions. So if it's best to, it may be best, or I recommend that you change them into decimals to do the operations for the mx plus b part. So let me show you how that looks. So I went ahead and set them equal, and you don't have to wait. You can go ahead and change them into decimals right away. But I waited a second before I changed them into decimals. I'm going to subtract or add 5x on both sides. Add 5x on both sides. And when you change this to a decimal and then add the 5x, you'll get 18 is equal to 5.8x. And over here, I went ahead and changed the 3 over 5 to a decimal. And you could type this in your graphing calculator, do 4 divided by 5. Actually, you cannot. Just do 4 divided by 5 in any calculator, and you'll get your decimal, and you'll add it with whatever number or subtract it with whatever number you're dealing with. All right, so I've done that. Now I have 18 is equal to 5.8x plus zero point 0.6. So now I'm going to subtract the 0.6 on both sides. The 18 minus the 0.6 is going to get me 17.4 is equal to 5.8x. All right, now I'm going to continue to solve for x, isolating x here. I'm going to divide by 5.8 on both sides. And once I do that, I get this nice round number 3 here. So my x is equal to 3. Now all I have to do is take this and substitute it back in to find what y is. So I decided to take this equation here, y is equal to negative 5x plus 18, seems to me the easiest one to work with, and take this 3 and plug it in. So now I got negative 5 times 3 plus 18. Y is equal to negative 15 plus 18, and that's going to get me y is equal to 3. All right, so now I have 3 is equal to x and y is equal to 3. And so my coordinates is going to be 3 comma 3. And that's how you solve a system of equations by substitution. Let's go back over your steps. All right. So steps here are going to be set each equation uh, equal to y. So you have it in y equals mx plus b format. Set the mx plus b parts equal to each other. Solve for x, and then substitute the x in so you can find the y. Then write your coordinate. Again, I want to thank you for checking out A1 Math and have a nice day.